Okay, this is lecture 28, and you'll recall that we are in section 21.3 talking about water balance. We got into talking about water intake at the end of last lecture, and so now on your lecture outline, we're picking up with the regulation of water intake. And notice here then you're being referred on page 809 to figure 21.1. And let's take a look at that table. So again, regulation of water intake. Basically, when do we drink? What causes us to drink? And let's go through the table then, and we can abbreviate and not worry about some of the detail here. So let's go over what I'd like you to know then. Number one then, the body loses water. Number two, osmoreceptors in the hypothalamus detect this water loss. Number two again then, osmoreceptors in the hypothalamus detect this water loss. Number three then, we feel thirsty as a result. And of course, we drink as a result. And then let's jump down to number five. And so this water that we have taken in is absorbed, taken out of the digestive system, and we've restored our water level. So moving on now from water intake to water output, and average daily water output. And let's go back now. Notice you're being referred to page 808, back to figure 21.5, and now the B part of the diagram, so the lower right-hand part of page 808. And average daily water output then, as you would expect, if water is going to be in balance, output is going to equal input. You'll recall average input per day is 2,500 milliliters. And so now we're just saying, and therefore average water outlook is also 2,500 milliliters, 2.5 liters per day. You'll notice also then the B part of the diagram is set up in the same way as that A portion with the figure that we talked about last time. So now talking about water output and four major components of water output. And so from your lecture outline then, and from the B part of the figure, water lost in sweat accounts for about 6% of outlook. Number two then, water lost by evaporation. And notice here two different parts to this number two. So water lost by evaporation from the skin and water lost by evaporation from the lungs. And together then, number two, this water lost by evaporation makes up about 28% of input. Number three, water lost in feces, about 6% of output. And the majority then, number four, water lost in urine, about 60% of total water output. In terms of regulation of water output, and here now you might want to jot down, we're going to take a look at table 21.2, table 21.2 on page 809. And so events in regulation of water output. And notice then the table is divided into two parts. So what happens when we're dehydrated? And number two, right part of the figure, right part of the table rather, what happens when we've taken in excess water? Looking at dehydration, and here just summarizing, and notice then dehydration causes the hypothalamus to signal the posterior pituitary. Dehydration again causing the hypothalamus to signal the posterior pituitary to release ADH. And of course, as a result of this ADH release, urine output decreases, and so we're now conserving water. Again, if we're dehydrated, obviously we want to take steps to conserve water. And then the right side of the table, if we've taken in too much water, again, it's the hypothalamus signaling the posterior pituitary. In this case, notice then secreting or inhibiting rather the posterior pituitary from releasing ADH. And of course, if less ADH is being released, then urine output will increase. And therefore, we're getting rid of, obviously, some of this excess water that we've taken in. So on to 21.4 now, and talking about electrolyte balance. So we're moving away from water balance. We're talking now about electrolyte balance. And on your lecture outline then, notice the kidneys alter electrolyte losses to maintain the proper concentration of body fluids. And this, of course, comes as no big surprise since you guys are familiar by now with the kinds of things that the kidneys are doing in this process of electrolyte balance. In terms of electrolyte intake then, most of our electrolytes come from the food that we eat. In terms of regulation of electrolyte intake, this intake is mostly simply regulated by hunger. And so we eat when we're hungry, and this provides the necessary electrolytes. In terms of electrolyte output then, you might just want to jot down that this output of electrolytes is mainly in urine. And in terms of regulation of electrolyte output, on page 813, if we take a look at figure 21.7 and also 21.8, just as a couple of examples of regulation of electrolyte output. And let's take a look, and this is review. You guys are familiar with this from chapter 13 when we were talking about endocrine system and talking about hormones. So looking at 21.7 then, again, just as an example of the regulation of electrolyte output. And notice here now we're talking about plasma concentration of potassium, and we're also talking about sodium. And let's just run through those several steps. So within the blood, potassium ion concentration increases. Following along then, the adrenal cortex secretes aldosterone. The next box then, responding to this release of aldosterone, the renal tubules increase the reabsorption of sodium. And this should be ringing a bell again. And also then in that third box down also, there's an increase in the secretion of potassium ions. And of course, the last box, as a result then, sodium ions are conserved and potassium ions are excreted. Looking at figure 21.8 on page 813, again, just another specific example of the regulation of electrolyte output. And so up at the top then of that figure, you can see we're talking about plasma calcium ion concentration. We could talk either about an increase or a decrease. In this example, we're talking about an increase in blood calcium. And of course, the goal then would be to get plasma calcium levels back down to normal. Just following along to that second box, you'll recall that the parathyroid glands are involved in decreasing blood calcium. The hormone is parathyroid hormone. And I don't really want to take the time or to hold you guys responsible again for the rest of the figure then, the various ways in which parathyroid hormone causes a decrease in blood calcium levels. And we'll stop here and pick it up next time talking about 25.1 acid-base balance.